a very simple law, and you may have already seen some notes on this already, but it's such a cornerstone for things we're going to work on in the days and weeks to come that I thought a little video was in order. So enjoy. Our concept of the law of reflection requires that we think about an object that has light reflecting off of it. And we just saw in a separate set of notes the ray model of light. So let's put a ray into our picture and observe how that ray is incident on the green surface I just drew. So there is our ray of light. In yellow, it originated up here somewhere, came straight down. As light does, it travels in a straight line through empty space or through air, and it is incident on our green surface right there. I didn't quite get the ray all the way down to the surface, but we can imagine where it would touch right there. We know that light reflects off of surfaces, so we can ask ourselves, what is the direction of the ray of light that reflects off the surface at this location? And to help answer that question, we apply what's called the law of reflection. The law of reflection speaks to the angle at which the light comes in, and then some other angle at which the light goes away from that surface. A very important thing about the angles that we talk about is what we measure those angles to. By convention, we don't measure the angle to the surface. Instead, we measure the angle to the perpendicular to the surface. So I'm going to show us how we do that in just a moment. So I've introduced a protractor to our illustration, and that protractor is arranged so that it is laid right along the green surface, and we can see that we could use that protractor to measure the angle that the yellow ray is incident on the surface at. And as we said, by convention, we don't measure the angle to the surface, but instead the angle to the normal to the surface. So in black, I've added a normal to the surface, and we can measure the angle of incidence relative to that normal. That is the angle I'm about to point out right here. It is this angle right there. And we're going to call that theta sub I for angle of incidence. So what is that angle of incidence exactly? Well, we can just measure it right off the protractor. It is not 10, not 20, not 30, not 40, but about 42 degrees. And now you can ask yourself, where does the ray go after it bounces off that green surface and continues on its way, having been reflected? There is one correct and very specific direction that ray will go. And if you thought something like that looked right to you, well, your instincts were very good. Kind of feels a little bit like a tennis ball bouncing off a tennis court, right? It comes in at a particular angle, bounces away at the same angle, but on the other side of some imaginary perpendicular line that it came in relative to. And you saw just a moment ago, I took some pains to have the yellow reflected ray go in just the right direction. The angle the yellow reflected ray makes is, of course, also 42 degrees. So we see that the angle it comes in at and the angle it reflects at are the same angle, giving us what might be the simplest equation we're going to learn all year, which is the angle of incidence equals the angle of reflection. That is the law of reflection. Thanks for watching. And again, the important thing to remember, we took these measurements off of the normal. And that's something that we're going to see again in this course in a slightly different context. But we want to get used to making that measurement not off of the angle of incidence, but instead off of the normal. Theta sub I is equal to theta sub R.